Okay, we have a cosmic ray proton moving toward the Earth at 2.891 times 10 to the 7th meters per second, and experience a magnetic force of 13.1 times 10 to the minus 16 newtons. What is the strength of the magnetic field if the angle between the velocity and the magnetic field is 40.5 degrees, right? Well, this is again a charged particle, a proton, moving in a magnetic field, right? And so what are we after? Again, we're after the whole equation. Um, we start here, right? Q V cross B. We have we know the angle between them, and so we can rewrite the magnitude of the force as QVB sine of theta, the angle between them, right? All right. Um, so we know the velocity, 2.891 times 10 to the 7th meters per second. We know the force, 13 times 10 to the minus 16 newtons. We know the angle, and what we're after is the magnetic field. And we also know the charge, because the charge on the proton is 1.6 times 10 to the minus 19 coulombs, right? And we're going to solve for the magnetic field. So our magnetic field is F over QV sine theta, right? So this is our formula. B is F over QV sine theta. So B is going to be 13.1 times 10 to the minus 16 newtons divided by 2 point or 1.6 times 10 to the minus 19 coulombs times 2.891 times 10 to the 7th meters per second times sine of 40.5 degrees. All right, so pretty simple problem in the end. Let's pop over to Excel and get our formula in place. So we have our force, 13.1 times 10 to the minus 16th. We have our charge, 1.6 times 10 to the minus 19th. We have our velocity, 2.891 times 10 to the minus 10 to the 7th. And we have our angle, which is going to be radians. We have to use the radians function because Excel only uses radians of 40.5, right? And now we need to find the magnetic field, which is the force divided by the charge times the velocity times the sine of the angle. And so we get 4.36 times 10 to the minus 4. It asks for us in micro Tesla, right? So divide that by 1e minus 6. That's a 10 to the 2, so 436 micro Tesla. (436 micro Tesla). And that's it for problem 3.